Hello, everybody. Let's look at the hot subject of AI today. The title of my presentation for today is Navigating the AI Odyssey, 3 Decades of Innovation, Practical Applications, and Future Perspectives. I received my PhD in Systems and Control Engineering from Case Western Reserve University in the year of 2000. I'm a fellow member of ISA, International Society of Automation. This presentation was an invited talk at IEEE Boston Tech Conference on April 12, 2024, right before the day of Boston Marathon. Here's the agenda for the whole presentation. First, I'm going to talk about the history of AI. And second, I'm going to walk through some of the engineering applications of AI. And third, I'm going to go look at the generative AI and the recent breakthroughs. And also, I'm going to look at the technical interest on AI and how we can collaborate in the future. After that, I want to review with you the future challenges caused by AI and also AGI, artificial general intelligence, and the ethic issues that we have to face together. AI has a long history of over 70 years. The first meeting on AI was organized at Dartmouth University in New Hampshire. This labeled the beginning of artificial intelligence era. From the very beginning, symbolism and connectionism evolve in parallel. Symbolism is looking at rule-based system, connectionism looking at the neural networks. And most recently, we have seen a breakthrough in large language models using deep learning, uh, using the type of transformers. ChatGPT is the typical software that people are using today. Here on this slide, we have more information about the symbolism or symbolic AI versus connectionism, the neural network-based AI. The advantage of expert systems is that you have explicit rules and it's easy to interpret the inference process. Neural network, on the other hand, is considered to be a black box model. So it's a long time competition, but that evolve in parallel, as we said before. So this slide talks more about the neural network, which is connectionism, and it evolves from a simple neural network model to today's complicated deep learning model. Some scientists and engineers try to integrate symbolism and connectionism. One example is a neural fuzzy system. That means in the neural network, they put the fuzzy logic into it so that we can take the advantage of rule-based system like fuzzy logic, and also the neural network machine learning method. Now let's look at the shorter time window, which is the latest 30 years. So before 1990s, rule-based system kind of dominates in AI study, and the neural network tend to be more silent. But from mid to late 1990s or 2000, neural networks start to be studied more and used more. So that's the transition from symbolism to connectivism, but both still exist. So, and the foundation for modern AI with deep learning happens around 2006 or 2005. And from 2006 to 2010, there's a rapid expansion and integration of the deep learning neural network thing into the applications. So like ImageNet or integrate that into many digital tools. Yeah, from 2015 to 2020, we've seen a lot of applications like autonomous vehicles, healthcare applications, media applications, so on and so forth. And in 2020, with the presence of GPT-3 and GPT-3.5, also known as ChatGPT, a lot of people have concerns of the ethic side of AI, and in particular, future presence of AGI, artificial general intelligence. And 2023, large language model and multiple models, large models are being used more, and we got more applications in generating text, image, audio, and mostly video as well. And the representative software include Cloudy, ChatGPT, and Gemini. We have reviewed the AI history very quickly. Now that we switch to the industrial applications of AI, we start with this one, which is the power plant applications in 1990s. This is as part of my dissertation at Huazhong University of Science and Technology. And in this thesis, we use both fuzzy rules and neural network for power plant, uh, for detection, diagnosis, and monitoring. This industrial application of AI is about advanced barrier fault diagnosis. The work was done at Case Western Reserve University with a focus on signal processing, data modeling. The use of neural fuzzy work was done after 2000. The paper was published on mechanical system and signal processing uh, in 2003 and 2004, that time frame. This neural fuzzy system is what MATLAB or MathWorks provided in the fuzzy logic toolbox instead of the neural network toolbox. So this is a very interesting one, and this paper can be found on the internet. And I also recorded a video with a detailed explanation on the fault detection method using wavelet and the neural fuzzy network, which is listed here. This industrial application for AI is about the use of neural network to construct a dynamic model using simulation data for model pre-control studies. The first author, Vinaya Joshi, was a graduate student at University of Connecticut. Dr. Pete Lu was his advisor. Dr. Pete Lu was my friend and collaborator. He passed away 2 years ago, unfortunately. We have worked together a number of applications. He's a great mentor of myself as well. He's a good friend of my advisor, Dr. Ken LaPro. So we published 3 papers in series at ISA Power Industry Symposium. The 2007 paper is the MPC using boiler simulation data, but using linear model-based predictive controls. 2008 is a paper of nonlinear MPC using this nonlinear AX model. And 2009 paper is a study on how to generate the data using different exciting signals so that we can generate a very high quality model. So that's deeper research into the modeling part using data-driven approaches or machine learning approaches. So that paper also won the second place in ISA Power 2009 Symposium. Okay, this industrial application for AI is about using neural network modeling for real power plant data we collected from AESMs. AESM is fluidized bed power plant in Connecticut. And at that time, we collaborated with AES very closely because the power plant is about an hour's drive from where we are in the Hartford area. So Paul Panos, the CAB engineer, and I travel to the power plant very frequently. And Joshi was also involved to help develop and maintain the neural network model and a genetic algorithm while he was a co-op student from University of Connecticut. And Connie Schaefer was my manager, and he's a technical specialist on controls optimization as well. Um, Dr. Pete Lu also served as advisor while he was working from UConn. Dr. Ming Yi was sent from UConn to work on this as well. Dr. Ming Yi is now a principal engineer at ISO New England. So basically, this is an offline tour using both neural network and genetic algorithm to do perform optimization of the power plants, looking at heat rate, looking at NOx emissions, and also the limestone utilization and the disposal costs. This industrial application for AI is about fault detection using dynamic simulation data generated by GE. The deep learning algorithm was developed by GE Research. The project was sponsored by US DOE's National Energy Technology Lab. So this deep learning based detection structure was proposed and developed by Dr. Yiwei Fu and Dr. Feng Xue, who works at GE Research. And the GE Power provides the simulation data for normal situations and different fault situations and at different load levels and with different levels of noise is added to the simulations. So the project also looked at the field test data collected from the real power plant. So Dr. Feng Xue was the PI. He's now with GE Aerospace. Dr. Yue Fu is now with GE Vernova, with GE's energy business. So here, this is a presentation I did at a recent Pittsburgh co-conference. The focus was on how to generate dynamic simulation data, how to support the evaluation of fault detection algorithm using deep learning. And here, this reference is Dr. Yiwei Fu's paper and Dr. Feng's paper as well. So with the details on deep learning algorithm for fault detection. Gen AI or generative AI marks the breakthrough of large language model and deep learning in the past years. Evolution of Gen AI is from early times to the latest transformer models, which is basis of ChatGPT and other Gen AI tools. The transformer model was developed by 8 engineers at Google, but all of them have left Google now. But transformer model was successfully used and implemented by OpenAI in the ChatGPT tool they put on the website. We look at more how Gen AI is different from classification AI and how it's different from predictive AI. This slide is meant to explain how generative AI is different from classification AI. Classification AI is typically used for like fault detection or data clustering. So with the fixed classes of outputs, but generative AI need to generate new data. So it's different. Like you can write the new text, generate new images, music, or visuals. So it's different. It's a big step from classification AI. And this slide is meant to tell the difference between predictive AI from generative AI. Predictive AI aims to forecast future events or trends based on historical data. The focus is on accuracy of prediction and the likelihood of future occurrences. It's the learning and the prediction. Generative AI is focused on creating new content. That means learning and create. That's the major difference. Now let's move to the topic of common technical interest, and let's discuss how we can collaborate as a team. Here I share a picture or slide that I found from the internet. I put source from internet. You can find this easily by typing top AI use cases. This is a very good summary. So you can use that for a lot of business, R&D, and engineering applications, and financial applications as well. So by looking at this, I hope we can be inspired to develop some AI applications that can add values to the field of our common interest, either health, education, energy, transportation, and the finance. You name them. Yeah, here I'll give example how we can use ChatGPT, the tool, to develop custom GPT for our special purposes. And this one is example for diagnostic consulting support using AI. So I created using GPT-4. So this type is research analysis. And after you chat with ChatGPT, GPT will generate the template and list the questions, the top questions here. And then this instruction basically is the series of prompts that you're gonna better define the scope and style of the custom GPT application. For example, the language style, you want to define that, use professional always, or you can use Carol always, or you can let GPT know, can we use the language for high school student level or for international uh, users level. So you can specify the style, you should always ask the user instead of guess, or you can encourage the GP to guess so that they can generate some answers with the imaginations. But sometimes we call it hallucination. So we have freedom to define this. For scientific or technical consulting support, normally we want to define the professional language style. We want to be concise. We want the GPT to ask questions before it actually proceed to guess. So this is where you can put more instructions here to specify how GPT will work or team up with the users. So this slide give continued explanation on how we can configure custom GPT. So here under the knowledge part, we can add the files, either reports or publications. Like this is my paper, and these two my friend's paper on fault detection and diagnosis. And we can add more like the standards or anything that's accessible but in the public domain. And if it is your internal project, you can put your internal documents as well. Um, and here is example. You can put the question, a single prompt question, and to get your answer. And you can test it and to tune it the different way to make customer GPT work better. You can upgrade this to a GPT team so that a team of people can work together on tuning and testing. And also you can apply for a GPT Enterprise where you can apply for access to fine tuning, means you can train the model partially using your prepared data set. So to make your custom model more efficient and more accurate and more consistent. On the GPT platform, a lot of users are kind enough to create custom GPTs using their own domain knowledge and share them in the public domain. Uh, of course, they using non-proprietary, non-confidential knowledge for such public applications. But if you want to develop proprietary application, you should keep it private. So, and this one is a renewable interconnection, and the author, Dr. Zhang, is a grid operation expert or smart grid expert. So you can use this. There are similar applications on the GPT platform as well. And you can develop your own custom GPT on renewable energy, for example, for your specific purpose by yourself. So this slide continue from the last slide. This slide aims to show how we can use the application, the custom GPT, to get answers we want. And this custom GPT is for healthcare application. This slide continues from the last slide, and this basically shows how we can use this custom GPT to ask question with a single prompt and get the answer we need. This is an example of custom GPT in the education field, and this is demonstrate how we can use a prompt to get answer education. Now let's move to the next subject, future challenges and ethics. In general, the challenges include these aspects. Other privacy concerns. There's governance and regulation issues, and there's accountability and transparency of AI applications. And AI will automate a lot of work and replace the current work done by humans, which will cause unemployment. And there's bias and fairness. Can we ensure the AI application can deliver fair and equitable outcomes? One of the impact is on energy and electrical power. Uh, the training of large language model consume a lot of electrical power, and it's give the power grid a lot of pressure. So there's different way to deal with this. First, the AI company try to put the data center, put the training machines facilities in different states, So the load, electrical power can be distributed, but this causes other problem like the data communication between the different training centers. Another method is to increase the training efficiency. Uh, for example, the transform model was developed 6, 7 years ago by the Google team. Can we advance this model structure using a better or more efficient model design? That's a question to all of us. And third is looking at, can we design the chips better? So the GPUs that we use as the training infrastructure, can that be higher frequency design in the future? Look at the brain uh, power consumption when we think we do intelligent work. So the power consumption is very low and the energy efficiency is very high. So this leads us to ponder more general question like this. The silicon-based intelligence, is that really comparable with the carbon-based intelligence, which is the human intelligence? Yeah, another challenge is the impact of AGI, uh, artificial general intelligence. AGI is considered to be human level intelligence or even higher. So on the positive side, AGI will help people to do better work. Um, and AGI can enhance fraud detection effectiveness. Um, but there is associated ethic concerns as well. So how we can maintain the dependence and the trust when AGI is to be used. We're approaching AGI according to OpenAI and other companies, and how we can regulate the compliance. Talk about the AGI, the human level intelligence or beyond. This video give us a lot of more insight, like post-labor economics caused by AGI. That means when AGI can do a lot of work people can do today, so the economics will be totally different. The whole economic society need to be redesigned and reconfigured. So that means we don't have to work on all the tedious coding work, for example, and people can be trained to do other work. This slide continues from the last slide on post-labor economics caused by AGI. So here, the slide basically shows more detailed discussions. You can get into this YouTube video. So by searching um, um, post-labor economics, and you can look at the whole video by yourself, and also this video as well. Let's talk about the uh, future economics and future society will be reshaped by AGI, and how we as humans can get better prepared to still drive the AGI as the master. And thank you for working with me till this point. Let's summarize what we have reviewed in the past 30 slides. Uh, so first, AI has experienced a great breakthrough in the past few years, and symbolism and connectionism are not competing approaches. And as today's technology rely on neural networks, we should think about integrating symbolism into the neural network, the deep learning work, and make it more efficient and make the inference of machine learning large language model more transparent. And electric power can be a bottleneck for today's machine learning method, but we have several methods which may give us solutions. Ethics of AI can be a concern, but we should still have a positive attitude. We need to address the privacy, cybersecurity, social impact, and economic impact. So, how to handle this? That need a lot of investment from the government to do early time research. And we can work together and collaborate on something on AI applications. Uh, my personal interest is energy, healthcare, and education. So I look forward to work with you. Again, thank you for paying attention to my presentation on AI. Um, again, my name is Xinsheng. I'm a fellow member of ISA, International Society of Automation. I also serve as a volunteer leader, direct elect for ISA's Power Industry Division. I also serve as AI consultant. Tech and Service LLC is um, consulting firm registered in the state of Connecticut. So this is my Gmail and this is my LinkedIn profile. I'm looking forward to talk with you more. If you send me email or connect me at LinkedIn or send me through LinkedIn, we can talk more and work on this exciting topic together. Thank you.